Hello dear students, so our next question is, select the correct order of acidic strength of oxides, right? Student, if we will talk about the acidic strength, then acidic strength is directly proportional to the positive oxidation state. If oxidation state will increases, then acidic strength will also increases, right? First one is SO2, then SO3, right? In the SO2, sulfur shows +4 oxidation state, and in the SO3, sulfur shows +6 oxidation state. So if oxidation state of the SO3 is greater than SO2, then it will has more acidic strength. So this is the incorrect order. Next is CS2O, K2O, then Na2O, right? So basically student, this is the normal oxides, and when we will move down to the group, then what happen? Then basic strength will increases, right? Then basic strength will increases. So now what happen here, because size increases here, basic strength increases. So this is not the correct order of the acidic strength. So this is the incorrect order. Now CO2, N2O5 and B2O3. In the CO2, carbon shows +4 oxidation state. In the N2O5, nitrogen shows +5 oxidation state. So we can say that N2O5 is more acidic in nature than CO2. So this is incorrect order. Now fourth is SO3. In the SO3, sulfur shows +6 oxidation state. In the CO2, carbon shows +4, and in the B2O3, boron shows +3 oxidation state. So if oxidation state is more, then acidic strength will be more. This is the correct order of acidic strength. So option 4 is the correct answer. Thank you. Hello dear students, our next question is, accession fluorine molecules has bond order 1. Reason, the number of electrons in the anti-bonding molecular orbitals is 2 less than that in bonding molecular orbital, right? So first of all, if we will talk about the fluorine molecule, student, fluorine molecule is contain 18 electrons. So according to the molecular orbital theory, first of all we have to find out the electronic configuration of fluorine molecule. So this is the sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz2, pi 2px2 equal to the pi 2py2, right? Then pi star 2px2 equal to the pi star 2py2, right? Now we have to find out the bond order, and bond order is equal to 1/2 non-bonding electrons. Basically, number of electrons into the bonding molecular orbital, then number of electrons into anti-bonding molecular orbital. So bond order equal to the 1/2. Then you can see here that totally 8 electrons are present into bonding molecular orbital, and then 10 minus 8. So we will find out the bond order, right? So now the number of electrons in the anti-bonding molecular orbital is 2 less than that in bonding molecular orbital. This is the true statement. So both the statements are correct, and you can see here A and R are correct, and R is the correct explanation of A. Option 1 is the correct answer. Thank you. Hello dear students, our next question is, we have to match the column first of diatomic molecule with the column second of bond order, right? So first is helium. If we are talking about the helium, is an inert gas, so helium does not form diatomic molecule, it exists into the single species, so we can say that bond order is 0, right? So A is matched to the fourth, you can see here. Li2 bond order is 1, C2 bond order is 2, and N2 bond order is 3. So option 1 is the correct answer. And you can write their bond order on the basis of MOT theory also, right? You can write their electronic configuration first, and after the electronic configuration writing, you can use this formula NB minus NA divided by 2, which is equal to the bond order, right? So NB is the number of electrons which is present into the bonding molecular orbital, and Na is the number of electron which is present into the anti-bonding molecular orbital, and you will find these bond orders. Thank you. Hello dear students, our next question is assertion catenation tendency is weaker in nitrogen, and the reason is single nitrogen-nitrogen bond is weaker because of high inter-electronic repulsion of the non-bonding electrons, right? Student, if we are talking about the catenation tendency, definitely catenation tendency of the nitrogen is very weak. Why? Because here nitrogen also contains this non-bonding electrons, right? So that's why whenever nitrogen forms single bonds, here non-bonding electrons are present, and due to the small size of the nitrogen, here inter-electronic repulsion will be present, and that's why here this nitrogen-nitrogen single bond will be weak, and that's why here it has weaker catenation tendency. So assertion and reason both are correct, and reason is also correct explanation of the assertion. So option 1 is the correct answer. Thank you. Hello dear students, our next question is match the column first with the column second. First is given elements and the second column is given ionization energy, right? So if we are talking about this, neon has highest ionization energy because it is the inert gas, so electron will not remove very easily, right? After that, if we are talking about that fluorine has high ionization energy, right, due to the most electronegative element in the in that second period, right? And after that, nitrogen and oxygen. Nitrogen, because it is half filled, it contains half filled orbital, so due to the presence of half filled orbital, it is not easily to remove the electrons from their outermost shell, right? So this is the correct order, and you can see option 3 is the correct match. Thank you. Hello dear students, so our next question is, which is the characteristics of oxygen molecule? Student, oxygen molecule O2 is contains 16 electron, and we have to calculate the electronic configuration of molecular orbital theory by molecular orbital theory of oxygen molecule, right? So sigma 1 is 2, then sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2. Sigma 2pz2 pi 2px2, which is equal to the pi 2py2. Then here pi star 2px1 equal to the pi star 2py1. This is the electronic configuration of oxygen molecule. You can see that oxygen molecule shows paramagnetic behavior. It shows paramagnetic behavior because it has two unpaired electrons in their anti-bonding molecular orbital. So it contains two unpaired electrons in anti-bonding pi orbital. So now first one is diamagnetic with no unpaired electron. Second, diamagnetic with two unpaired electron. Third is paramagnetic with two unpaired electron. So option 3 is the correct answer. It is paramagnetic with two unpaired electron. Thank you. Hello dear students, our next question is the correct order of acidic character is, right? Basically, when we move from top to bottom in a group, then acidic strength increases and basic strength decreases, right? So basically H2TE has most acidic character, and then H2SE, then H2S, and then here H2O. So option 4 is the correct answer. Thank you. Hello dear students, so our next question is the correct structure of ethylene diamine tetraacetic acid. So student, first of all, ethylene diamine. This is a structure of ethylene diamine. Then tetraacetate. So CH2 COOH, and here tetraacetate CH2 COOH. And similarly here tetraacetate CH2 COOH, and this is CH2COOH, right? This is the structure of ethylene diamine tetraacetate, right? So you can see that option 3 is the correct answer. This is ethylene diamine tetraacetate structure. Thank you. Hello dear students, our next question is, in which of the following complexes there is an outer orbital hybridization? So first one is zinc NH3 whole 6 2 plus, right? So student, in this complex zinc contain plus 2 oxidation state, that means it has electronic configuration 3d10, right? So you can see now here that d electron is completely filled. So if d electron is completely filled, then ligand NH3 will come at d, will come in the outer orbitals, right? So it will come into 4s, 4p and 4d orbital, and electronic configuration will be sp3d2, right? So we can say that this is the outer orbital complex. This is outer orbital complex, right? So option 1 is the correct answer. Now coming to the CONH3 whole 6 3 plus. In this complex, cobalt has plus 3 oxidation state. So if cobalt has plus 3 oxidation state, then electronic configuration will be 3d6. And if it has 3d6 electronic configuration with NH3, NH3 is a strong filled ligand. So if it is a strong filled ligand, NH3 is a strong filled ligand. So if it is a strong filled ligand, that what happened, pairing is the possible, and if pairing is possible, then you can see that here 2 inner orbitals are present, right? So that's why it will be inner orbital complex. Next is chromium NH3 whole 6 3 plus. So here chromium shows plus 3 oxidation state. So if chromium shows plus 3 oxidation state, then electronic configuration of the chromium will be, electronic configuration of chromium will be 3d3. So if it is 3d3, that you can see that here the inner d orbitals are present, which is vacant, right? So that means it is also inner d orbital complex, right? Next is vanadium NH3 whole 6 3 plus. So here vanadium shows plus 3 oxidation state, right? So here electronic configuration will be 3d2. Electronic configuration will be 3d2, right? So if it has 3d2 electronic configuration, then again vacant d orbital are present. So if vacant inner orbital are present, so it is also inner d orbital complex, right? So option 1 is the correct answer. Thank you. Hello dear students, our next question is match the following column first with the column second, right? First one is EDTA. So basically student, EDTA is used into the lead poisoning. So first is matched with the C, okay. Next is DMG. So DMG is used for the detection of Ni+2. So it is matched with the D. AuCN whole twice minus is used. This complex is used with the electroplating with gold. And the next is AgS2O3 whole twice 2 minus. This complex is used for the black and white photography. So option 4 is the correct answer. This is the compounds, this is the complex which is used in our daily life. So option 4 is the correct. Thank you. Hello dear students, our next question is, which of the following is the strongest base? We have to tell that which base is the strongest. Students, we know that basic strength, we know that basic strength is directly proportional to the donating tendency of lone pair. Donating tendency of lone pair. If nitrogen atom is contain lone pair and the nitrogen atom can donate lone pair in more amount, then basic strength will be more, right? Now we have first compound. In the first compound you can see here nitrogen atom is contain lone pair, and this lone pair can donated by the nitrogen, and this nitrogen is sp3 hybridized, right? In the second compound, nitrogen contain lone pair, but it is sp2 hybridized, and this lone pair is delocalized. This lone pair are localized on the nitrogen atom, right? It will not take participate into the resonance. Now here nitrogen atom is contain lone pair, it is sp2 hybridized because this lone pair is delocalized, it will take participate into the resonance, right? Here nitrogen atom is contain lone pair, it is sp2 hybridized because lone pair is delocalized, it will take participate into the resonance, and we know that when lone pair will take participate into the resonance, then it will not take participant into hybridization process, right? So now student, if we will talk about the strongest base, so the nitrogen atom which contain localized lone pair on it, that nitrogen can donate lone pair in maximum amount, and that will be more basic in nature. So we can say 1 and 2 more basic in nature than 3 and 4. Now we will compare to 1 and 2. Into the one, nitrogen is sp3 hybridized, and into the second compound, nitrogen is sp2 hybridized. So if electronegativity will be less, the nitrogen can donate electron in more amount and it will be more basic. So first compound is more basic in nature than second. Now we will compare to third and fourth. Into the third compound, aromaticity will come into the ring due to the presence of delocalization of the lone pair, right? So if aromaticity in the ring will come, that means it will be more basic, it will be least basic in nature, right? Because this lone pair will participate in resonance in more amount, right? So fourth will be more basic in nature compared to the third. Third is least basic. Question was asking about the strongest base, so first is the correct answer. Thank you. Hello dear students, our next question is match list first with list second. List first is contain molecular formula and list first is contain number of structural isomer, right? First molecular formula is C3H9N. Student, first of all, we have to calculate the degree of unsaturation when molecular formula is given. So we can use this calculation formula for the DU. C plus 1 minus H plus X minus N by 2, right? This is the formula to calculate the degree of unsaturation when molecular formula is given in a compound. So now here for the C3H9N, we will identify the DU is equal to 0. For C5H12, DU is equal to 0. For C3H7, Cl, du is equal to 0, and for C6H14 also du is equal to 0. If du is equal to 0, that means the compound is not contain any type of pi bond and any type of cyclic ring, right? Now first one is C3H9N. So 3 carbon atoms are present and 1 nitrogen, that means NH2. That means by using this molecular formula we can form this primary amine. Next this amine. Next will be secondary amine, and the next will be tertiary amine. So now student, you can see that we will use, by using this molecular formula, we can draw 4 structural isomers, that means A is matched with third. Now the second is C5H12. So for this C5H12, 5 carbon atoms are present in a straight chain. Next will be 4 carbon atoms are present in a straight chain and 1 carbon atom are attached as a methyl at this carbon. Next will be 3 carbon atoms in a straight chain, and this is here. So now you can see we can draw 3 structural isomer by using the C5H12 molecular formula. So B will show 3. Next is C3H7Cl. C3H7Cl is contain 3 carbon atom and 1 chlorine group are present. So chlorine group can be attached at this position, at this primary carbon, and chlorine group can be present at this secondary carbon. So by using this molecular formula, we will draw the the 2 isomers. Next is C6H14. So C6H14 is contain 6 carbon atom. So first of all, 6 carbon atom are present in a straight chain. Then 5 carbon atom are present in a straight chain and 1 carbon atom are attached at this carbon as a methyl group. Next will be here 1 carbon atom here as a methyl group, and 4 carbon atom are present in a straight chain. Then we are having 2 carbon atom and these 2 carbon atom are attached at this carbon, right? We can draw one isomer when 4 carbon atom in a straight chain and 2 methyl groups are present at only 1 carbon atom. So totally you can see by using this molecular formula C6H14 we can draw 5 structural isomers. So option 4 is the correct answer. This is the correct match of list first with list second. Thank you. Hello dear students, our next question is we have to tell the final major product A of this reaction sequence, right? We have this ethyl benzene and this ethyl benzene will heated with caminophore. Caminophore is a strong oxidizing agent, so basically it will turn this ethyl group, it will oxidize this ethyl group into the carboxylic acid, right? So finally the formation of benzoic acid will take place. Option 1 is the correct answer. Thank you. Hello dear students, our next question is, statement 1 is eclipsed form of ethane is more stable as compared to staggered, right? So this is the false statement, student. Basically this is the staggered form of ethane and this is the eclipsed form of ethane. Clear? So if we are talking about the stability, then we know that eclipsed staggered form is more stable because here less van der Waals strain and less torsional strain are present, right? So staggered form is more stable, so this statement is false. Second is stability of conformation depends on van der Waals strain and torsional strain. Yes, true. This is the true statement. Basically, stability of the conformation depends only on how much strain are present there, right? Eclipsed have much strain as comparatively staggered. That's why eclipsed is least stable. Clear? So a statement 1 is incorrect, but sir, second is correct. Option 4 is the correct answer. Thank you. Hello dear students, our next question is Prussian blue color is, right? So first of all, student, if we are talking about the Prussian blue color, this Fe4 Fe Cn whole 6 whole thrice point XH2O. This compound is Prussian blue in color, right? So option 1 is the correct answer. And this complex compound is formed when the organic compound is contain nitrogen and it will undergo to the Lisane test for the detection of the nitrogen. So option 1 is the correct answer. Thank you. Hello dear students, our next question is which of the following is our adsorption chromatography? So basically column chromatography and thin layer chromatography is an example of adsorption chromatography, but paper chromatography is an example of partition chromatography. So option 4 is the correct answer. Thank you. Hello dear students, our next question is what is the main product of the reaction between 2-methylpropene with HBr? Student, this is the 2-methylpropene. 2-methylpropene. And this compound react to the HBr. So basically what happened by electrophilic addition reaction? By electrophilic addition reaction is proceed and this alkene and addition of the HBr on this double bonded alkene will take place, right? So first of all what happened, this reaction is proceed by the Markovnikov rule. This reaction is proceed by the Markovnikov rule. And in this rule what happened, first of all this rule says that electrophile will go to that carbon atom which contain more number of hydrogen, and we know that this carbon atom is contain 2 hydrogen. So this electrophile will go to that carbon atom which contain more number of hydrogen, and nucleophile will go to that carbon atom which contain less number of hydrogen. So we will get here this is the compound 2-bromo 2-methylpropane. 2-bromo 2-methylpropane. This is the major product of this reaction, and option 4 is the correct answer. Thank you. Hello dear students, our next question is we have to tell the final product D in this reaction sequence. Clear? So now student, we have C2H5Cl and this compound will react with the KCl. Cl minus is a nucleophile, it will attack at this electrophilic side and the Cl minus will releases. So our A product will be C2H5Cl. Now this compound A will undergo hydrolysis. So basically when this will undergo hydrolysis, here we have cyanide group. So this cyanide group will undergo hydrolysis, and after the hydrolysis of this cyanide group we will obtain here carboxylic acid. This is our B. When this carboxylic acid is treated with ammonia in presence of the high temperature, then there is the formation of amide group will take place. This is our C product. Now this C will further react to the Br2 in presence of a base. So basically what happened, we have amide group and this amide group will treat it with the halogen in presence of a base. So Hoffman bromamide degradation reaction will proceed and our final product will be this amide group will convert it into the primary amine. This is our major product D of this reaction sequence. Option 2 is the correct answer. Thank you. Hello dear students, our next question is statement 1. The chlorofluorocarbon compounds of methane and ethane are collectively known as freons. Yes, chlorofluorocarbons are known as freon. True. Second is it is manufactured from CCl4 by Schwarz reaction. Again, this is a true statement because by using the Schwarz reaction, it is converted into the CCl2CF2, right? So it can be formed. So basically both statements are correct. Option 1 is the correct answer. Thank you. Hello dear students, our next question is an unknown alcohol is treated with the Lucas reagent to determine whether the alcohol is primary, secondary or tertiary. Which alcohol reacts fastest and by what mechanism, right? Student, basically we have alcohol and this alcohol is treated with the ZnCl2 in presence of the concentrated HCl, right? This ZnCl2 in presence of the concentrated HCl is known as Lucas reagent and this reaction is proceed by the SN1 mechanism. And what happened in this reaction? In this reaction, formation of the turbidity of alkyl chloride will take place, right? So because reaction is proceed by the SN1 mechanism, then the alcohol which can form more stable carbocation that will give us turbidity immediately, right? So 3-degree alcohol react to the fastest rate, then secondary alcohol and primary alcohol will not give us turbidity, and if it will give us turbidity after heating on 30 minutes, right? So basically this is the correct order of the alcohol to react with Lucas reagent. Now the question is, an unknown alcohol is treated with the Lucas reagent to determine whether the alcohol is primary, secondary or tertiary. Which alcohol reacts fastest? So tertiary alcohol reacts fastest because it can form more stable carbocation. And by what mechanism reaction is proceed? Always by SN1 mechanism. So tertiary alcohol by SN1, option 1 is the correct answer. Thank you. Hello dear students, our next question is the product formed between the reaction of sodium phenoxide and ethyl iodide is, right? So basically here we have this sodium phenoxide, O minus Na plus, and it will react with the ethyl iodide. So student, basically this alkoxide this alkoxide ion can behave as a base and as well as nucleophile also, but here we have primary alkyl halide. So with the primary alkyl halide, it will behave as a nucleophile. It will attack at the nucleophile and here this I minus will releases. So formation of ethoxybenzene will take place, OCH2CH3. This compound is known as phenetone, right? So here option 1 is the correct answer. Thank you. Hello dear students, our next question is CH3COCH3 and CH3CH2CHO can be distinguished by. Student, you can see that one compound is ketone group contained and the one compound is contained aldehyde group, right? So basically to distinguish the mixture, to distinguish the compound in a mixture, reagent should be given, test should be given one reagent and compound, and the other compound should not given by test, should not given the test by the same reagent, right? First one is neutral FeCl3. Neutral FeCl3 test only given by the phenol, so both the carbonyl group, aldehyde and ketone not give this test. Next is tolerance reagent. Students, aldehydes can give tolerance test, but ketone group will not give tolerance test, right? So option 2 is the correct answer. By tolerance reagent, we can identify the ketone and aldehyde in a mixture, right? Because aldehyde give tolerant test but ketone will not give. Next is sodium bisulfite test. Carbonyl compound, both the ketone and aldehyde group can give sodium bisulfite test. Next is 2,4-DNP test. So yes, aldehyde and ketone both will give us 2,4-DNP test, right? So only tolerance reagent is the correct answer, which is given by aldehyde but not given by the ketone. Thank you. Hello dear students, so our next question is, identify A and B in the following reaction. First one is acetic acid. and this acetic acid will react with the A reagent and we will obtain CH3CH2OH, that means alcohol. And the B is acetic acid react to the B reagent and we will get ethane. We will get here ethane, CH3CH3. That means acetic acid completely converted into the alkane, right? First one is HI plus red phosphorus and lithium aluminum hydride, right? Student, if we will talk about the reagent A cannot be HI red phosphorus because HI red phosphorus will converted the acetic acid into alkane, right? So basically we can say HI plus red phosphorus can be our reagent B because this reagent converted the acetic acid into alkane completely reduction of the acetic acid. Now this is the partial reduction, not the fully reduction. So A reagent should be lithium aluminum hydride. Lithium aluminum hydride will reduce the acetic acid into this alcohol. So first is not the correct answer. Second is nickel heat and lithium aluminum hydride. Lithium aluminum hydride cannot be B reagent because lithium aluminum hydride will convert acetic acid into alcohol, not the alkane. Lithium aluminum hydride and HI plus red phosphorus. Option 3 is the correct answer. A will be lithium aluminum hydride and B will be HI red phosphorus. Option 4 is PTPSO4 and zinc HCl. Zinc HCl will not convert acetic acid into alkane, right? It will not give us completely reduction. And PTPSO4, similarly PTPSO4 not convert acetic acid into alcohol. So option 3 is the correct answer. Thank you. Hello dear students, our next question is, ethylamine can be obtained from an ethyl thalamide on treatment with, right? Student, this is a structure of an ethyl thalamide. This is an ethyl thalamide, and when this an ethyl thalamide is heated with hydrazine. When it is heated with hydrazine, then what happened? Basically, formation of hydrazide will take place. So here, formation of this ethyl hydrazide will take place and we will get ethylamine as a product of this reaction sequence. So option 4 is the correct answer. Thank you. Hello dear students, so our next question is, we have to tell the product C in this reaction sequence. First one is amide group, and this amide group is treated with the NaOH plus Br2 and we will get a product in this reaction sequence, right? Student, when amide group is reacted with the bromine in presence of NaOH, then what happened? Formation of amine will take place. Formation of primary amine will take place because reaction is proceed by Hofmann-bromide reaction, right? So our A product will be cyclopropane amine. Now what happened? This cyclopropane amine will undergo carbyl amine reaction with chloroform in presence of a NaOH. So in the carbyl amine reaction, this primary amine will converted into foul smelling compound which is isocyanide group. So our B product is isocyanide. Now this B will undergo reduction with lithium aluminum hydride. So when this B will undergo reduction with lithium aluminum hydride, then formation of this secondary amine will take place. So this is our final product C of this reaction sequence. Option 1 is the correct answer. Thank you. Hello dear students, our next question is, which among the following bases is absent in RNA, right? So basically adenine, guanine, cytosine and uracil are present in RNA, but thiamine is absent in RNA and it is present in DNA. So option 4 is the correct answer. Thank you.
So students, the next question here is from the mole concept chapter. The number of electrons in 1.6 gram of methane. First we are going to determine the number of moles. So the formula here for mole is equals to mass in the unit of gram upon molar mass. So this is the formula for the calculation of mole. So mole of CH4 is equals to the given mass is 1.6 gram and the molar mass is 16. So we get 0.1 mole. Now we have to determine the number of molecules. So the number of molecules is equals to mole into Avogadro's number. Here the value of mole is 0.1 and the value of Avogadro number is 6 into 10 ki power 23. On solving this, we get 6 into 10 raised to the power 22 number of molecules of methane. Now we have to determine that how many electrons are present in one molecule. So here we have 1 carbon and 4 hydrogen atoms. Clear? So the number of electrons in the carbon, here 6 and 12 atomic number and mass number. So the number of electrons are 6 and number of electrons in the hydrogen is 1. And as because here 4 atoms are present, so total electrons are 4 according to the hydrogen. Now the total electron in one molecule. If we want to find out that the total number of electron in one molecule is 10 electron, then the total electrons here are 6 into 10 raised to the power 22 into 10. That is equals to 6 into 10 raised to the power 23 electrons present in the 1.6 gram of methane, which is given in the option number 3. So students, the next question is from the atomic structure. The question is the radius of second Bohr's orbit of hydrogen atom. So here the energy shell number is second and atomic number is 1 because it is hydrogen atom. Now the radius formula is 0.529 into n square by z angstrom. So it is in the unit of angstrom. And if we want to convert it into nanometer, then we must have to put this value of angstrom, that is 10 raised to the power minus 10 meter, and 0.0529 into n square by z into 10 raised to the power minus 9 meter. And 10 raised to the power minus 9 meter is what? Nanometer. So 0.02529 into n square by z nanometer. Clear? Because options are in nanometer. Now we have to put the values of n and z. So radius second orbit is 0.0529. The value of n is 2 square and for z it is 1. On solving this, we get 0.2116 nanometer. So this is the radius of second Bohr orbit of hydrogen atom. Hence option number 3 is the correct choice. So students, the next question here is match the column 1 with column 2. So column 1 contains some electronic configuration. Column 2 contains some atom or ions. So let's start with the column 2. The first will contains the chromium plus 3. So here we have chromium and chromium plus 3. So let's start with the chromium. The atomic number of chromium is 24 and its electronic configuration is argon 3d54s1. Actually this is the exceptional electronic configuration. And in the first part we have chromium plus 3. So for chromium plus 3 we have to remove the 3 electrons. So let's remove the 3 electrons from here. So its configuration of chromium plus 3 is argon and 1 electron is removed out from the 4s orbital and 2 from the 3d5. So we get 3d3 as the electronic configuration for chromium plus 3. Now the third one is scandium. So scandium has atomic number 21. So its configuration is argon 3d1. Now the fourth will contains the copper plus 2. The atomic number of copper is 29. So its configuration is argon 3d10 and 4s1. But we have to remove 1 electron. So 1 electron will removed out from the 4s subshell. Now the fifth one will contains titanium. So its atomic number is 22. So its configuration is argon 3d2. Now let's check that which one is the correct match. So argon 3d54s1. Argon 3d54s1 is the correct match for the chromium. So for P, second is the correct match. Now Q part is argon 3d10. So argon 3d10 is for copper plus 1. So copper plus 1 is present in the fourth. Now the R is argon 3d3. So argon 3d3 is for chromium plus 3, and chromium plus 3 is present in the first part. Now the S is argon 3d1. So argon 3d1 is correct for scandium, and scandium is present in the third part. So according to this, the correct match is given in the option number 3rd. So students, the next question here is the number of radial nodes in 2p and 4s orbitals respectively are. So if we calculate the number of radial nodes, then it is n minus l minus 1. So let's start for the 2p. For 2p, if we count the radial node, then the value of n is 2. For p, the value of l is 1 and minus 1. So the radial node are 0 in 2p orbital. Now 4s. In 4s, if we calculate the radial node, then the value of n is 4, the value of l is 0, minus 1, that is equals to 3. So 0, 3 is the correct radial node for respectively 2p and 4s orbitals. Hence option number 3rd is the correct choice. So students, the next question is from the thermodynamics, which is an extensive property. We know that the physical properties are classified into two categories, that is extensive and intensive. The properties which depends upon the number of particles are called extensive, while which do not depend upon the number of particles are called intensive. So temperature is an intensive property. Chemical potential is also an intensive property. Molar volume is extensive, but as because it is fixed for 1 mole, then it must be intensive property. The only extensive property is Gibbs free energy, because it depends upon the number of particles. Hence option number 3 is the correct choice. So students, the next question is from the thermodynamics. The question says that if gas at constant temperature and pressure expands. So basically we have a gas, that is the number of moles are fixed, and it is expands at constant temperature and pressure. Constant temperature means what? Delta T equals to 0. And we know that the internal energy, that is delta E, or you can also say that QV is equals to NCV delta T. Here delta T is equals to 0. It means delta E is also equals to 0. That is, change in internal energy will become 0. And change in internal energy is what? It is E final minus E initial is equals to 0. It means E final must be equals to E initial. If final and initial internal energies are same, then it means internal energy will remains constant or same. Hence option number 3rd is the correct choice.
Okay students, coming to the next question. Our next question is, in a closed insulated container, a liquid is stirred with a paddle to increase the temperature. Which of the following is true? Okay, here you will see that we need to find delta E, W and Q basically. So here you will see that it is a closed insulated container. Okay, closed insulated container, that means what? Basically the value of Q will be equals to 0. The value of Q will be equals to 0. Here we have our first law of thermodynamics as delta U is equals to Q plus W. Here we have given that it is an insulated container, so the value of Q will be 0, and if the value of Q will be 0, the value of delta U is equals to W. Here you will see that liquid is stirred with a paddle to increase the temperature. That means work is done on the system, so it cannot be equals to 0. So basically delta U is equals to W, or this will not be equals to 0. Okay, so here you will see that our correct option will be option number 1, that is delta E or delta U will be equals to W, which is not equal to 0, and Q is equals to 0, that is option number 1.
So students, next question is from the chemical kinetics. The question is, which of the following values of equilibrium constant predict almost completion of the reaction? So equilibrium constant is basically product upon reactant. The reaction completion means almost all the reactants is consumed and converted into product. It means what? Product value is very higher than the reactant value. So reactant value is very lesser. It means K, higher the value of K shows that the reaction is almost proceed towards the completion. And out of these four options, the maximum value is given in the option number 4, that is K equals to 10 ki power 4. So this value represents that the reaction is almost go for the completion. So we can say that option number 4 is the correct choice here. So students, the next question is from the ionic equilibrium. The question is formic acid. Formic acid means HCOOH is 4.5% dissociated. So HCOOH is the acid and its degree of dissociation is 4.5%. It means 4.5 into 10 raised to the power minus 2. So here this is the value of alpha. Clear? Now in a 0.1 N solution, so normality here is 0.1 N at 20 degrees Celsius, the ionization constant of formic acid. So we have to find out the ionization constant of this formic acid. Clear? So here we have to apply the formula, and remember that here the normality and molarity will be same, because normality is equals to molarity into N factor. In case of acid, the N factor is equals to the number of H plus ion releases, and here formic acid will decomposes into HCOO minus and H plus, so its N factor is 1. So normality or molarity both are same, that is equals to 0.1. So this is basically the concentration. This is basically the concentration given in the question. Clear? Now we have to find out the value of K. So HCOOH is decomposes into HCOO minus plus H plus. Let's suppose its initial concentration is C, which is already given, that is 0.1, but just suppose we assumed as C. HCOO minus and H plus are 0. At equilibrium, let's suppose alpha is the degree of dissociation, which is 4.5% here. So the remaining concentration is C minus C alpha. We can also write it C1 minus alpha. This is C alpha and this is also C alpha. Now we have to apply the formula for the ionization constant, that is equilibrium constant. So K is equals to concentration of HCOO minus into concentration of H plus upon concentration of HCOOH. So K is equals to, it is C alpha upon C1 minus alpha, and here as because alpha is less than, here alpha is less than 5%, so we can neglect it from the bottom side. That is 1 minus alpha will becomes 1 alpha, and 1 C will be cancelled out here. 1 C will be cancelled out, and 1 minus alpha can be write as normal 1. So K is basically C alpha square. Now put the value, the C, that is the concentration is 10 raised to the power minus 1. The concentration is 10 raised to the power minus 1, and the alpha value is 4.5. 4.5 into 10 raised to the power minus 2 square. This is the value of alpha here. Now we have to solve this value. So on solving this value, we get K is equals to 2.1 into 10 raised to the power minus 4, which is given in the option number 4. So this is the correct ionization constant of formic acid. Hence option number 4 is the correct choice. So students, the next question is from the redox reaction chapter. The sum of the oxidation state of all the carbon atoms present in the compound, that is benzaldehyde, is. So basically in this question we have to find out that what is the sum of oxidation states of all atoms of carbon present in the benzaldehyde. It means we have to find out the oxidation state of all the carbon atoms individually and then sum of these. Clear? If you directly calculate it by the X method, then that is the average oxidation state. So don't do that, just simply calculate one by one. Here first we have to Draw the complete structure of benzaldehyde. So this is clear. Now we have to find out the oxidation state. This is +1, so this is -1, +1, -1, +1, -1, +1, -1, +1 and -1. So these are the 5 carbon atoms. Here this carbon is sp2 hybridized, this carbon is also sp2 hybridized. So both have same electronegativity, so they do not generate any charge on each other. But due to this hydrogen, this is +1, this is -1, this is -2 and this is +2. Now let's sum up all these. So here total +2 and here from -1, 1, 2, 3, 4, 5. Total 5 -5. On solving this, we get -4 as the oxidation state. So option 1 is definitely correct. We have another method. The another method is C6H5CHO. You have to don't determine the value of X. Let's suppose the oxidation state of carbon here is X. So what? It is 6X plus 5 into 1 is the oxidation state of each hydrogen. The oxidation state of carbon is again X. For hydrogen it is 1, for oxygen it is -2, and as because it is compound, so we equate it equals to 0. Now total X is 7X plus 5 and 1 6 minus 2 barabar 0. On solving this, we get 7x is equals to -4. Now, as because we have to find out the value of all the sum of oxidation state of all the carbon atoms, so it is 7x, not the x. So 7x is equals to -4, or you can also use this structure format. In both the cases, the correct option is -4, which is given in the option number 1.
Well, students, our question is 1 mole. Each of the following solutes are taken in 5 moles of water. So we have been given some solutes. This is A, we have been given NaCl, K2SO4, Na3PO4 and glucose. So assuming 100% ionization of of the electrolyte, so the relative decrease in the vapor pressure will be in order. So basically we have to observe the correct increasing order of RLVP. These are the increasing order. So we have to identify the correct increasing order. Now see students, we know that relative lowering of vapor pressure is basically a colligative property, and colligative property depends upon the number of moles of solute, and these are electrolyte. Out of 4 we are having 3 electrolytes. So the value of I will be the governing factor for the order, right students? So the value of, if the value of I increases, relative lowering of vapor pressure also increases. If the value of I increases, the value of relative lowering of vapor pressure also increases. So for this particular case, now see students, for NaCl, it will be dissociated as Na plus and Cl minus, and we have been given that this is a 100% dissociation case. So for this, the value of I comes out to be 2. So this is A. For B, this is K2SO4. So this will be dissociated as 2K plus and SO4 minus 2. So I comes out to be what? 3. For this C, we are having Na3PO4. So this will be dissociated as 3Na plus and PO4. 3 minus, so I comes out to be 4. And the last is students, glucose. Well, glucose is a non-electrolyte. So this won't be associated, neither it will be dissociated. So I will be what? 1. So the one which is having the highest value of I will be having the highest relative lowering of vapor pressure. So amongst these, the highest value of I is for Na3PO4, which is C. So C will be having the highest RLVP, which is followed by B, because the value of I for B is coming out to be 3, which is further followed by A for NaCl, which is 2. And the last is D. So the correct order will be what? D, A, B and C. This will be the correct increasing order. So the correct answer goes to be option number 3. Thank you. Well students, our question is, vapor pressure of pure A is 70 mm of Hg at 25 degrees Celsius. It forms an ideal solution with B in which mole fraction of A is 0.8. If the vapor pressure of the solution is 84 mm of Hg at 25 degrees Celsius, the vapor pressure of pure B at 25 degree Celsius will be Watt. Okay. So initially we have been given that the vapor pressure of pure A is 70 and it forms ideal solution with B, which is having a mole fraction of 0.8. If the vapor pressure is the vapor pressure of pure B at 25 degrees Celsius, that means we need to identify what? We need to identify the value of P naught B in this particular case. Okay, students. Well, we all know that PS or PT is what? This is P naught A XA plus P naught B XB. Well, we have been given that the vapor pressure of the solution is 84. So this is given to us equals P naught A is 70 into XA. XA will be what? Mole fraction of A is 0.8 plus P naught B into XB will be 1 minus 0.8, that is 0.2. Okay, so P naught B into 0.2 is equals to, this will be 84 minus 7, it's a 56. So this will be 56 over here, and 84 minus 50 will be what? This will be 34 minus 6, that is 28. Okay, so this is 28. So P naught B will be 28 by 0.2, that is 28 into 5, and 28, 8 5 is 40, and 5 to the 10, and this will be 140 mm. So the vapor pressure of pure B is 140 mm of Hg. That means the correct answer is the fourth option, and I hope you got the concept. Thank you.
So students, the next question here is, select the incorrect pair of cathode and anode respectively as per the cell mentioned. So this is the memory based question. The dry cell. In dry cell, the cathode is formed by graphite rod while the anode is formed by zinc container. So this is the correct. Clear? Now the second one is mercury cell. Paste of mercury and carbon, zinc mercury amalgam. So yes, this is also correct. The lead storage cell contains grid of lead packed with lead sulfide and lead oxide. So this is not basically the lead storage battery composition, if you remember. So fourth one is nickel cadmium cell, nickel 3 hydroxide and cadmium. So this is also true. So the incorrect pair is only given in the option number 3. So students, the next question here is the oxidation potential of hydrogen electrode at pH equals to 10 and partial pressure of H2 equals to 1 atm. So pH is equals to 10 means the concentration of H plus ions is equals to 10 ki power minus 10, and the partial pressure of H2 given here is 1 atm, and we have to find out the oxidation potential of hydrogen electrode. So oxidation potential, the oxidation reaction is H2 will, or half of H2 accepts, half of H2 releases an electron and produces H plus ion. This is the oxidation reaction. Now E oxidation potential is equals to E naught, standard oxidation potential, minus 0.0591 upon N log of product upon reactant. So H plus concentration upon partial pressure of H2 gas. Now put the value EOP, and the standard oxidation potential or standard reduction potential of the hydrogen electrode is 0. So it is 0 minus 0.059 upon 1. Here change of electron is what? 1. Log of the concentration of H plus ion is 10 raised to the power minus 10, and the partial pressure of H2 is 1. Now on solving this, we get the oxidation potential. Oxidation potential of the hydrogen electrode is 0.59 volt, which is given in the option number 3. So students, the next question here is match the column 1 with column 2. We have two column and we have to match these. So column 1 will contains some symbols and column 2 contain its name. So this is the symbol of molar conductivity. So for P, third is the correct match. K is basically the conductivity, so fourth is correct match. This is rho, and rho is the symbol for resistivity. So first is the correct match, and G star is the cell constant. So second is the correct match. So for P, third is the correct one. For Q, fourth is the correct one. For R, 1 is the correct one, and for S, 2 is the correct one, and this correct set is given in the option number third. So students, the next question is from the chemical kinetics. The question is for the reaction is N2O5 gives 2NO2 plus half of O2, and the given things are minus dN2O5 upon dt is equals to K1N2O5. dNO2 by dt is equals to K2N2O5 and dO2 by dt is equals to K3N2O5, and we have to find out the relation in between K1, K2 and K3. So for this chemical reaction, first we are going to write down the differential rate equation. So rate is equals to minus dN2O5 upon dt is equals to 1 by 2 dNO2 by dt is equals to 1 upon 1 by 2 dO2 by dt. Clear? So this is the differential rate equation. Now we are going to put this value one by one here. So minus dN2O5 by dt is K1N2O5. So this value is basically K1N2O5, that is equals to half of dNO2 by dt is K2N2O5. So it is half of K2N2O5, that is equals to, it is 2, and it is K3N2O5. The N2O5 will cancel out here because it is common in all these three. Finally, we get K1 is equals to K2 by 2 is equals to 2K3. Now multiply whole this with 2. So it is 2K1 is equals to K2 is equals to 4K3, and it is correctly given in the option number 1. So students, the next question here is from the chemical kinetics chapter. 5 milligram radioactive sample. Radioactive sample means what? The order of reaction is first. 90% disintegrate in 3 years, then 99% disintegration will be. So basically 90% disintegration is given in 3 years, and we have to find out the 99% disintegration time. So basically this is first order reaction, and throughout the reaction the value of rate constant is same. So the K is equals to 2.303 by T log A naught upon AT. So this is the value. Clear? Now in both these cases, that is 99 and 90%, K is same. So we are going to equate both these. So first for T 90%, it is 2.303 by T 90% log of A naught. Initially suppose it is 100%, and after 90% disintegration only 10% will remains. Now is equals to, for T 99% it is 2.303 by T 99% log of, suppose initially it is 100% and after 99% disintegration it will remains 1. Now put the value and cancel out the common terms here. So the common term is 2.303 is the common here. Now the rest values are, so T 90% is basically 3 years given. It is log 10 means 1, that is equals to 1 by T 99%. It is log 100 means 2 log 10, and log 10 means what? Its value is 1. So T 99% is 3 into 2, that is equals to 6 years. So 6 years are required to disintegrate the 99% of this radioactive substance. Hence option number 3rd is the correct choice.